Hello. Welcome to our analysis of an analytical geometry question. And it's a question two, possibly from a test or assignment that I was given. And in the diagram, you've given a E, which is a point in the circumference of the circle with midpoint O and E being the midpoint of BD. And BC intersects the x-axis at M. Right. So first things first, the circle has a center at O. That's one thing to identify. So if it has a center at O, because they did not indicate anywhere that M is the center, so you cannot mistaken that information. So the first starting point is to determine or give the equation of the circle. And the equation of the circle, let's say this is 2.1 for a circle with a center at 0, 0. Well, both of them come from the general equation x minus a squared plus y minus b squared, which is equals to an r squared. Now, if the center is a 0, 0 point, you'll have to say x minus 0 squared plus y minus 0 squared equals to an r squared, which means now this is just x squared plus y squared equals to r squared. That's the general formula of the equation of this circle. Now, the only thing we can find here is r. Now, where do we find r? If we check in our diagram, MO cannot give you r. BO can give you r, which is the radius. And also starting from O to C and O to D, but all of those do not have coordinates. The only one that has a coordinate and it's at the circumference, it's A. So finding or determining the length of AO will help us get the radius. So it means that radius R is given by the length of OA or distance, which can be found by determining the distance x2 minus x1 squared plus y2 minus y1 squared. Now you have O, which is 0, 0, A, which is the point negative 5 is to 12. Negative 5 is to 12. And you can check here it's x1, y1, and x2, y2. Then if you substitute in here, you get minus 5 minus 0 squared plus a 12 minus 0 squared. You can simply punch this in a calculator, then you get that r is equals to 13. Now, the first question wanted us to determine the equation of the circle, of which we know the general formula is x squared plus y squared equals to r squared. Now, the only thing we have to do is just substitute our value of r squared. So this is x squared plus y squared is equals to open bracket 13 squared, which the equation is x squared plus y squared is equals to 169. Second question is asking us to write down the coordinates of B and D. Now, where is B? B is where the y-axis, B is where the circle cuts the y-axis, of which is when x is equals to 0. And then D is where the circle cuts the x-axis and means y is equal to 0 there. So now we'll go on with the equation. B is where x is equals to 0. So now you're just going to rewrite the equation x squared plus y squared equals to 169. And you substitute for 0 here, then you solve for y. That's 169. Now that's y squared is equals to 169. I like to rewrite this before doing the squaring to ensure that I have written my plus or minus sign instead of doing everything at once. Right. So then you proceed through to say y is equals to plus or minus sorry, y is equals to plus or minus 13. Now, when you check B, B is where the y-axis is positive. So therefore, B will be y is equals to positive 13. I mean, the y-coordinate of B will be y, and therefore, such that B is a 0 is to 13. Next up, you're looking for D. Now, with D, that's where y is equals to 0. Same thing, equation equals to 169, and then x squared plus 0 squared equals to 169. You simplify it to say it's x squared is equals to 169. And then rewrite it 169. Then apply the square root on both sides, and don't forget plus or minus. Sorry, and x is now equal to a plus or minus 13. Where D is at, it's on the positive side of the Cartesian plane. Therefore, x will be equal to a positive 13. X is equals to positive 13, and therefore D is a 13 is to 0. What will you do with that information? Let's check in the next question. Determine the equation of EO. Determine the equation of EO. Equation of EO, as you can see, EO is perpendicular. That's, I think, theorem 1 in Euclidean geometry, whereby you have BE being equal to ED. So EO, if BD is a straight line, then EO is perpendicular, which means we can find, since now we have the coordinates of BD, we can find the gradient of BD in order to find the gradient of EO. So, first thing to do here, 2.3, 2.3, right, we see that BD is a line such that it's perpendicular to EO. And therefore, we can calculate the gradient of BD using y2 minus y1 over x2 minus x1. Now, BD is just these. 0 is to 13, and D being 13 is to 0. So this is my x1, y1, x2, y2. And then we can now substitute our values. Y2 is a 0 minus 13 over a 13 minus 0, which gives us negative 13 over positive 13, which equals to minus 1. If we say that MBD, I mean the line BD is perpendicular to the line of EO, this means that when you multiply the gradient of BD with the gradient of EO, we're going to get negative 1. Now BD is minus 1 times MEO, which is minus 1. Therefore, the answer, we divide both sides by negative 1. We get M of EO being equals to positive 1. Now, to find the equation, because the question said it was the equation in the format AX plus BY plus C equal to 0, which means we're going to say Y minus Y1 equals to MX minus X1. Now, Y minus, for EO, we only have O as the coordinate. So we're going to substitute them in here. Is equals to positive 1x minus 0. Then this gives us y is equals to x. Now they said they wanted the equation in the format ax plus by plus c equals to 0, which means we shift everything to the left. So this becomes a minus x plus y equals to 0. Last question. The last question is saying, what is the magnitude of AMO? Correct to 2 decimal places. This one is a lengthy one. I think it deserved that 5 marks instead of the previous one. But anyway, what is the magnitude of AMO? Now we see A has coordinates, M has coordinates, and O has coordinates. So which means they can form a type of a triangle. So what do we do with that? Um, let's look at AMO. We have the point A here being -5 is to a 12. And we have the point M being -3 is to 0. And then we have point O being 0 is to 0. Now, we did calculate the value of AO, which is equal to 13. The one that we don't have is MO and AM. So we are looking for this angle here, angle M, which means we need to find all the sides and use cosine rule. But first we need to calculate all the sides. So let's start by calculating AM. AM comes from the coordinate A, which is -5 is to 12, and M, -3 is to 0. Is to 0. Alright, then we label x1, y1, x2, y2. AM from the square root of x2 minus x1 squared plus y2 minus y1 squared. Now this is equal to a -3 minus -5 all squared plus a 0 minus 12 all squared, of which in the calculator gives us 2 root 37. Next one, MO. MO coming from M with a -3 is to 0 and O with a 0 is to 0. Now MO can be calculated also with the distance formula x2 minus x1 squared plus y2 minus y1 squared. And label x1, y1, this is a 0, x2, y2. Substitution, this is 0 minus a -3 squared plus 0 minus 0 squared, which is equals to +3. Then we go to our distance formula straight from the formula sheet, and we're gonna get from the formula sheet is written as a squared equals to b squared plus c squared minus 2bc cos of a. Right, before we get to that, let's go back to the diagram that we drew here. We're looking for this angle, so the formula has we'll have to label actually to say that this is angle A, this is side A, this is side B, and this is side C, in order for us to easily substitute from the formula. So side A, it's AO squared equals to MO squared plus AM squared minus 2 times MO multiplied by AM cos of angle M. And substitution, 13 squared equals to a 3 squared plus 2 root of 37 squared minus 2 times 3 and 2 root of 37 cos of m. Do the simplification to say this is 13 squared minus 3 squared minus 2 root 37 squared equals to negative 2 multiplied by 3 times 2 root of 37 cos of m. And you divide on both sides by the negative 2 multiplied by 3. Why am I putting a square root? Multiplied by 3, then 2 root of 37 all over negative 2, 3 root of 37. Well, it's 2 root of 37 and close. Now we're going to be left with this is an equal sign. We're going to be left with cos of m is equal to negative square root of 37 over 37. Then we look for the reference angle, which is equals to arc cos, the positive one, which is square root of 37 over 37. And we get a 80.54 degrees. Now, for angle M, it's going to be equal to 180 minus the reference angle. And that is 180 minus 80.54, which is equals to 99.46 degrees. Right. And yeah, that's each and every one of those questions answered.